All right, so here we are, Physical Science 20. We're looking at Chapter 14. We are beginning our study on curved reflectors. So we've talked about plane mirrors, we've talked about reflections in plane mirrors, and now we're going to talk about reflections and what the characteristics are in curved mirrors. So you see down here, we have a curved mirror. If the light is coming in from this way and it's curved this way, this is called a converging mirror. Okay? So here's your notes here. You might have to fill in some spaces here with your notes. It says this. It says, if you pay attention, you will start to notice that you see curved mirrors all the time in everyday life. They can be thought of as part of a glass sphere that has been cut away. Okay, so it's a cutaway of a glass sphere. So this is sort of a two-dimensional representation down here, this diagram. If the part that is cut away curves towards us at the edges, we call it concave. A concave mirror is also called a converging mirrors, and converging mirror, and that's because right here here's some rays that are coming into the mirror, and they'll bounce off this mirror and they'll pass through this little point right here. It's called the focus, and so they converge to one single point. That's why it's called converging. Okay, so you've got an object over here, and in a concave mirror like this, the light rays all converge to one point. And this point, of course, is called the focus. If the part that is cut away curves away from us at the edges, it's called a convex mirror. Okay, so here's the diagram for a convex mirror, just to clean this up a little bit. And so as the rays come in, if it's curved like this way, then you can see that the light rays will actually not converge to a point in front. They will actually diverge from a point behind the mirror. And those are the rules that light rays follow on a diverging mirror. Okay, a diverging mirror. And as we had mentioned before, I guess that was a convex mirror. Okay, convex is diverging. Okay, so the whole idea of this focus is really important. On a converging mirror, the focus is in front of the mirror. And in a diverging mirror, the focal point is beyond the mirror. And so you get, the same sort of behavior of the light rays, except with the focus being in a different spot, you get very different images. Okay, so that's the difference between converging and diverging. Here in 14.2, we'll talk about some definitions, some terms that you need to know. So when we're talking about a reflection in a converging mirror, which is specifically what we're talking about in 14.2, there are four key words that you need to know in order to describe the situation. So principal axis is the first one. The principal axis is this axis right here that travels through the center of the mirror and the principal focus. So it would be good for us to talk about the center. The center of curvature, I guess the center of the mirror, really is over here, I suppose. The center of curvature is right here, and this would be what would be the middle of the sphere, okay, that would create this mirror. And so the distance from this point to the mirror is exactly the same anywhere you go. So that's like the distance from the center to the center of curvature to the middle of the mirror or to the mirror would be the radius of what would be that sphere. All right? Okay. Now, the radius of curvature, that's what I just talked about. So the principal focus would be the next thing we need to know about. And that is, of course, what we just learned. All the light rays that travel parallel to the principal focus will all bounce off and travel through the focus. So any light rays that are parallel to the principal axis travel through the principal focus. And it's exactly halfway between the mirror and the center of curvature. So C, the C value, if you cut that in half, you get F. Okay, the focal length. And focal length is the final thing that we need to understand, and that is simply the distance from the mirror to the focal point. So this is the focal length. And when we're talking about lenses, or even the nature of curved mirrors, focal length is very important. That's kind of what we talk about a lot. That determines what the curvature of the mirror is, or what the curvature of the lens is, when we're going to talk about lenses later. That focal length. Okay, any questions on that? All right, so as we move through, here's a little note here, I guess. If the light rays do not come in parallel to the principal axis, so remember we talked about light rays coming in parallel to the principal axis, travel through the principal focus. If they do not travel parallel, and that is always equidistant from this line, so they travel like this. If they don't travel like that, but let's say they come in at a different angle, they'll still bounce off the mirror, and they will meet somewhere, but it won't be the principal focus. Instead, it will be a point that is still on what we call the focal plane. So that is the imaginary line that is perpendicular to the principal axis, so it makes a 90 degree, but it's not at the focus, it's down or up or somewhere, but it's on that focal plane. Okay. And this should be I think. This plane right here is parallel to the center of the mirror, so it would be like parallel to this, and perpendicular to the principal axis. All right, any questions about that? Okay. So there's a lot of predictability when we're talking about converging mirrors. Not quite the same as plane mirrors, but there's a lot that is the same, which we'll talk about here. So when we're talking about images now, where do we find the image in a converging mirror? Well, when you have a plane mirror, and a plane mirror, of course, is a mirror that is not curved, right? It is straight. It's a bad straight line, but let's pretend that's a straight line. Okay? And when we're talking about images there, they're very predictable. So this image would yield an image that is the same distance, right, from the mirror, and is exactly the same size and shape and everything like that. Well, with the curved mirrors, we get images that are distorted a bit. So it's not quite like this situation. With a plane mirror, the image is always behind the mirror the same distance away. So that's what we just talked about. Images are a little more complicated with a concave mirror. Now this is important though. The light rays still obey the same rules. They still obey the same rules as with a plane mirror. That is, the angle of incidence always equals the angle of reflection. The thing that changes, though, is that every single point on the mirror has its own little normal. And that's what I've tried to draw to show you here. So the normal, which is the line, the imaginary line that would be perpendicular to the mirror at any point, if you take a look at that, these little lines would represent normals, right? But they're all at slightly different angles to each other. So that means that each of the light rays, behave a little bit differently than the others. And not every single light ray is going to follow the same path. Okay. So there are 3 simple rules, though, for drawing ray diagrams, which will be the final part of this video here that I'll show you. Because it is still possible to identify where the image of this object would be. Okay? And so that's what we're going to find out next. Good? Okay. So here's the first rule, rule number 1 right here. A ray that is parallel to the principal axis. Now remember, you're saying, well, not all the rays are parallel. No, that's true. But if you think about this, the light rays from the tip of this object go out towards you and beyond, and left and right, up, down, in all different directions, right? It goes in all different directions. So there will be at least one light ray that will travel exactly parallel to the principal axis. And so what we do is we focus on that light ray. And the rule is this: if a light ray travels parallel to the principal axis and strikes the mirror, it will always travel straight through the principal focus. So that is rule number 1. So when we locate an image, what we want to do is we want to find out where these light rays from the object are actually going, and where they start to converge, or where they start to meet each other, is going to be where the image is going to be. So that's rule number 1. Rule number 2 is this. It's very, very similar to this one. A light ray that travels through the principal focus, so from any part of the object, and we usually use the tip when we're trying to do this sort of ray diagram work. If you draw a straight line through the focus and so that it hits the mirror, the predictability of this will be such that the light ray will reflect exactly parallel. Okay? So it's very similar to Rule 1. Rule 1 was parallel principal focus. This one is principal focus parallel. Okay? So the two rules, very, very similar. The third rule is the only one that's slightly different, but still pretty easy. Actually, maybe the easiest one. Any light ray that travels through the center of curvature and interrupts the mirror, okay, or hits the mirror, will travel exactly back on the original path that it came from. So there's just basically one solid line from any part of your object, let's say the tip of the object, through the center of focus. Through the center of curvature, sorry.
Again, a short track and field meeting in Mrs. Munson's classroom.
So when you put all this together, okay, I'm just going to erase this. When you put all this together, see on each diagram there's all 3 of the rays that are on there. I just highlighted the one I was talking about in each point. So this is number 1. Here's rule number 1. This one right here. I'll try and outline it just carefully here. Right? That's rule number 1. Here's rule number 2. Through the focus, parallel. And here's rule number 3. Through the center of curvature, right back on the exact same path. So when you do at least 2 of those rays, but if you can do all 3 of them and they hit the mirror, you'll see that they converge at a single point right here. See that? And so that's where the tip of this object, because we drew these lines from the tip of the object, that's where the tip of the object will be in focus. That's where the image will be, and it'll be in focus right here. So this is how we begin to locate our images. Okay? So we follow those 3 lines, and anyways, and so this right here is, I think we have more on this in another video here. So those are the 3 rules, and that's a little bit on converging and diverging mirrors. Good?